Unit 7, Day 3, Right Triangle Trig. Again, I'll teach it like it's from scratch, but it should be pretty familiar from geometry or physics. You definitely use it in physics. You guys have had those blocks on an inclined plane, sines and cosines. So yes, but we'll start from the beginning. The sides of a right triangle with an acute angle theta are always in the same ratio, no matter how large or small the triangle is. Right? So if opposite was here and adjacent was here, those ratios would be the same. Opposite to adjacent, opposite to adjacent. It doesn't matter how big the triangle is. It only matters what the angle is. And so that's why they're called the 6 trig ratios. We usually think of them as just sine, cosine, and tangent, but the reason they're called ratios is the size doesn't matter. It only depends on the angle. Okay, the sine of that angle is opposite over adjacent. Nope, opposite over hypotenuse. Hypotenuse. That's why we abbreviate things. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. SOHCAHTOA. You definitely did those in geometry. Did you do cosecant, secant, and cotangent in geometry? Look at you guys.
You should do the SOHCAHTOA dance.
I don't know the SOHCAHTOA dance. Maybe you could share that with us.
You don't remember the front of the
class.
Cosecant, remember we don't really memorize the other three. We just know who their reciprocal partner is. So cosecant is the flip of sine. So hypotenuse over opposite. Cosine and secant are reciprocal partners. So hypotenuse over adjacent. Tangent and cotangent are reciprocal partners. So adjacent over opposite. Big giant star next to that one because that's super important, but you probably already know that. To help remember these, we use the mnemonic device SOHCAHTOA. Or I'll throw Miss Morris under the bus for coming up with this, or she got it from somewhere. Some old hippie caught another hippie. Yep.
Yeah, but they don't know.
So just SOHCAHTOA is all you need to know. Whatever it takes. We said this already. Cosecant is the flip of sine. Secant and cosine are flips. Cotangent and tangent are reciprocal partners. So number one, again, that was Miss Morris's thing. That didn't come from me. So if you got a complaint, register that with Miss Morris. Find the 6 trig ratios for this angle, given the triangle on the right. Okay, tangent is opposite over adjacent. Except I don't even have opposite. Maybe I should label these first. Opposite, adjacent meaning adjacent to the angle, and the hypotenuse is always across from the right angle. So how can I find the opposite side? A squared plus b squared equals c squared. 2 squared plus b squared equals 3 squared. So 9 minus 4 is 5. So opposite is the square root of 5. Okay, back to tangent. Opposite over adjacent. Now I know the opposite. Root 5 over 2. Cosine is adjacent over hypotenuse. 2 over 3. Sine is opposite over hypotenuse. So root 5 over 3. Secant, I don't even remember what the letters are. I just know that it's the flip of cosine. So I flip cosine, and I get 3/2. So yeah, it's h over a, but don't remember it that way. Remember it as partners with cosine. Cosecant is partners with sine, so the flip of sine. 3 over square root 5, except we kind of don't like that because of the square root in the bottom. So 3 root 5 over 5. Cotangent is the flip of tangent. So 2 over root 5, we have to fix that. 2 root 5 over 5. Old news, right? I hope. SOHCAHTOA and the partners. It's helpful to remember the Pythagorean triples. You remember what that means? You know what that even means?
We're all three side lengths should be the same.
No. Pythagorean triple is for right triangles where all the sides are integers. So you definitely know one of them. You just don't know it's called a Pythagorean triple, I guess. What's the missing side in a... So 3, 4, 5. Do you know some other Pythagorean triples?
6, 8, 10.
Okay, 6, 8, 10. I'm not going to write that down because, yes, any multiple of this would count. So, yes, 6, 8, 10. 5, 12, 13. 8, 15, 17. These are all examples where a squared plus b squared equals c squared, where they're integers. And so these show up on PSAT and SAT a lot because if you know them, it makes life a little bit quicker and a little bit easier. If you don't know them, you can still find the missing side, but you got to go a squared plus b squared equals c squared. 7, 24, 25. I mean, they go on, and they're up, and away. But I would say if you know those first three, you'll be good. It just saves you time. Number 2. Find the 6 trig ratios for this angle. I'm going to label the pieces first. Probably many of you won't do that. I mean, you'll know what they are, but I'm less likely to make a silly mistake if I label opposite, adjacent, and hypotenuse. This time I'm missing adjacent, so I could do a squared plus b squared equals c squared, or I could look at those numbers and think, wait a minute, those look familiar. That must be an 8, 15, 17 right triangle. So I save myself a little time by knowing the Pythagorean triples. Cosecant. I don't even think about secant. I think about the flip of sine. So you know what? I'm going to answer the sine question first. Opposite over hypotenuse, which means cosecant is 17 over 8, because they are partners. Cosine, adjacent over hypotenuse. Caught another hippie. 15 over 17. And since we're finding all 6, I might as well go find secant, because I know secant is the flip of cosine. So 17 over 15. Tangent, TOA, opposite over adjacent. 8 over 15. Cotangent is the flip of tangent, so 15 over 8. SOHCAHTOA, the partners, right triangles. We'll also have some calculator problems. So grab a calculator, mine or yours, whatever. Some of these you may not have done in a while, so let's be careful here. Let's be careful for a couple of reasons. We definitely need to think about degrees versus radians. I mean, it's not hard to know which one you're in, but you got to remember to think about it. Sine of 79 degrees. Well, that's obviously degrees, so I need to make sure my calculator is in degree mode. So mode, degree, and then I can do sine of 79. 5 digits seems a little excessive, but 98163. You know what? Save ourselves a little bit of trouble here. How about instead of working them in order, which one do you think would be wise to do next?
Cotangent.
Yeah, let's do the other degree mode. That way we don't have to be switching back and forth as much.
How do you get cotangent?
How do you get cotangent? Because TI did not make the calculator with a cotangent button. How terrible of them.
Somewhere in math.
It is, and it is not hidden somewhere. It's not one of those. That's a good guess.
It's the inverse. It's the one with the negative.
Okay, now be careful. Inverse tangent means find me an angle whose tangent is 15. That's like going backwards. So it's not the inverse. Inverse means go backwards. But cotangent is the flip of tangent. So it's 1 over the tangent of 15. Okay. Now be careful. I hesitate to even write this. It is tangent of 15 all to the negative 1. But that is not the same as the inverse tangent of 15. So if by inverse you mean flip, you're right, but we don't ever say that with trig functions, because when we say inverse, we're talking about find me an angle whose tangent is 15. That's not what we're doing, though. So let's stick with 1 over tangent of 15. 3.732. All right, the rest are radians, so I can switch my calculator back to radians. By the way, if you ask me on the test day, do I need to be in radians or degrees, I will say it depends on what the problem is. Use the appropriate one. That's sort of my standard answer for that, because you can tell from the problem which one you should be in. So it's a good question to ask, like, what does my calculator need to be in? But I'm not going to tell you the answer. I'm going to tell you, look at the problem and figure it out. So part B, 3 pi over 7, that's a radian thing. Cosine 3 pi over 7, 0.22252. 0.22252, excuse me. Tangent of pi over 9. 0.36397. Cosecant. Again, TI did not put a cosecant button on your calculator. So how do you find the cosecant? Who's he partnered with?
1 over sine.
1 over sine. Okay, so I'm going to hit pause and let you do E and F to make sure you can find all those right buttons on the calculator. So 1 over the cosine of pi over 6. 1 divided by cosine pi over 6. 1.15470. 5 decimals. That's overkill. Okay, number 4. Now we want to go backwards. So we've got the answer. Find an angle find an angle whose sine is 2/3. That's what that means. I don't expect you to write this out every time, or probably even once, but what it means is find an angle whose sine is 2/3. That's where you inverse sine. So you want to go backwards. You want to tell your calculator to go backwards. And I don't know if you noticed this before, but they put lots of backward stuff together on the calculator, right? X squared and second x squared would be square root. Those are inverses. They undo each other. Log and 10 to the x, those undo each other. Natural log and e to the x, those undo each other. And then sine and inverse sine. Although what did it ask for? It asked for in radians, so make sure we're in radians. Inverse sine of 2/3. Find an angle whose sine is 2/3. Still going. Okay, now we're doing 3 decimals. 0.7297. I'll go 4 because I forgot to round the right way. So just put that extra 7 on there. If you got a calculator, it's super easy to check. It's almost dumb to check. If I do the sine of that answer, what should I get? What's the sine of 0.7297 going to be?
2/3.
It's going to be 2/3. That looks like 2/3 to me. All right, number B, or letter B, inverse tangent. Not till, for you it's tomorrow. Everyone else it'll be December 6th. A long time from now.
Yeah.
Inverse tangent of 9/2. 1.352. Inverse cosine of 0.3617. .201. Okay, part D, we need to really be careful because, again, TI did not give you a secant button for your calculator.
They should.
How dare they? So you certainly don't have an inverse secant button. So what do I know about secant?
It's 1 over.
Secant is 1 over cosine. All right, so watch this. I'm going to do this really slow this first time, and then you'll start to figure out the shortcut. So 1 over the cosine is equal to 5/3.
So it's 3/5.
So what's 3/5?
The inverse.
Let's don't jump there yet. That just means the cosine of the angle is 3/5. So now I can do inverse cosine of 3/5. .927. Now, very few of you are going to show all of those steps, and that's fine. Most people jump to that step and write that before they go to their calculator. Like, basically flip both sides. So if you flip secant, you get cosine. If you flip 5/3, you get 3/5. Then you've got something you can work with. So E and F are pretty similar, so I'm going to hit pause and let you do E and F. How about on F? How do I flip 2.5? It's like, yeah, don't overthink things. 1 over 2.5. And then inverse sine of 1 over 2.5. So those aren't hard, but please be careful because the inverse thing, we already ran into that issue. Like, what does inverse mean? Does it mean flip or does it mean go backwards? Well, yes, depends on what you're doing. So be careful using inverse. But if you're looking for an angle, you definitely have to do the inverse function, inverse sine or cosine or tangent. Sometimes you got to flip things over. So be careful. The main thing is remember who the partners are, show a little work, and you're less likely to mess things up. And that's it for today. So you're on to worksheet 3. And a reminder that due Friday is worksheets 1 through 3. So due Friday, worksheets 1 through 3. That's all we'll be doing Friday is turning things in.